4.3 Exponential Equations and Functions. Part 1, Solving Exponential Equations. Strategy for solving exponential equations. First, rewrite the equation in the form b to some power equals a to some power, or just b to some power equals y if there's only one exponential part. And then if b to the m equals a to the n, if you can rewrite it like that, if the base is the same, so if b equals a, then you can just set the exponents equal to each other. If b does not equal a, then take the log of both sides and apply the exponent property to get the variable out of the exponent and solve from there. If you have b to the m equals y, then from there just take the log of both sides and again apply the exponent property of logarithms. Whatever happens, solve the equation that you get after you've done this. So let's practice. If I have 2 times 4 to the 5x minus 2 equals 8 times 16 to the x. If I look at all of my bases, I have a 2, a 4, an 8, and a 16. I can rewrite everything with a base 2. So on the left side, I have 2 to the first times 2 squared to the 5x minus 2. If I simplify that, I have 2 to the first times, I'm going to distribute through my exponents there, and I get 2 to the 10x minus 4. And from here, if I have 2 to some power times 2 to some power, I can add my exponents. So I have 2 to the 10x minus 3. What about on the right side? 8 is 2 to the third, 16 is 2 to the fourth. So I have 2 to the third times 2 to the 4x. If I add my exponents, I get 2 to the 3 plus 4x. So now I have 2 to some power equals 2 to some power. And because 2 to the power is a one-to-one function, I can set those two exponents equal to each other. I have 10x minus 3 equals 3 plus 4x. Subtract 4x from both sides and add 3 to both sides. I get 6x equals 6. Divide by 6 and I get x equals 1. Here I have 10 to the 1 minus x equals 6 to the x. I cannot write a common base for both 10 and 6, so instead I'm going to take the log of both sides. Normally I take the natural log. In this case, though, I'm going to take the common log because we have a base 10 already. So if I do that, I have the log of 10 to the 1 minus x equals the log of 6 to the x. Now I can move my exponents in front, so I have 1 minus x times the log of 10 equals x times the log of 6. Now the log of 10, remember this is a base 10, so log base 10 of 10 is just 1. So this is equal to 1. So on the left side, I just have 1 minus x times 1. On the right side, I have x times the log of 6. Now, if I add x to both sides, I want to get all the x's on the same side. So I'm going to add x to both sides, and I get x plus x log of 6. Factor out an x, so I can combine my like terms. I get x times 1 plus log of 6. Then I'll divide both sides by 1 plus log of 6, so I can get x by itself. And I have x equals 1 over 1 plus log of 6. Let's try another one. 9 minus 2 times e to the 0.01x equals 1. I want to get the exponential part by itself to start, so I'll subtract 9 from both sides, and I get negative 2 e to the 0.1x equals negative 8. Then divide both sides by negative 2, and I get e to the 0.1x equals 4. Now I can write this in logarithmic form. So if I write this in logarithmic form, I have the log base e of 4 equals 0.1x. Divide both sides by 0.1, and I get the natural log of 4 divided by 0.1. Now dividing by 1/10 is the same as multiplying by 10, so I could rewrite that as 10 times the natural log of 4, which maybe looks a little better, but either answer is correct. All right, let's try another one. Here I have e to the 2x minus 3 e to the x minus 10 equals 0. What you could notice here is this is actually quadratic in form. If I let u equals e to the x and square both sides, I get u squared equals e to the x squared, which I can write as e to the 2x. So this is quadratic in form. I can write this as u squared minus 3u minus 10 equals 0. And now I'll solve for u. This factors to u minus 5 and u plus 2. So u minus 5 equals 0, or u plus 2 equals 0. u equals 5, or u equals negative 2. But u, remember, was e to the x. So either e to the x equals 5 or e to the x equals negative 2. So if e to the x equals 5, then we have x is the natural log of 5. If e to the x equals negative 2, well, we don't have a solution. Think about the graph. So e to the x looks like something like this, and negative 2 is down here. Those graphs would never intersect. So e to the x, a positive number to any power, cannot be a negative 2. That's not going to happen. So our only solution is x equals the natural log of 5. What about this one? Can we write this so it's quadratic in form? I have e to the x minus 3 e to the negative x equals 2. So I have an e to the x and an e to the negative x. One thing I can do here is I can multiply everything, both sides of this equation, by e to the x. Watch what would happen if I do that. I would have e to the x times e to the x minus 3 e to the negative x times e to the x equals 2 e to the x. So e to the x times e to the x, that's e to the 2x, minus e to the negative x times e to the x. If I add my exponents, negative x plus x is 0, so I have 3 times e to the 0, or 3 times 1, which is 3, equals 2 e to the x. Now if I get everything on one side, so I'm going to subtract 2 e to the x, I have e to the 2x minus 2 e to the x minus 3 equals 0. And this is quadratic in form, where again u would be e to the x, and u squared is e to the 2x. So sometimes you might need to do some kind of manipulation, figure it out, play with it, figure out something that might work. So write it in a form that you know what to do with. So I can write this one as u squared minus 2u minus 3 equals 0. So I have u minus 3 and u plus 1 equals 0. So u equals 3 or u equals negative 1. We've solved for u, now we need to solve for x. I know that u is the same as e to the x because that's what I decided it was. So either e to the x equals 3 or e to the x equals negative 1. So here x would be the natural log of 3. And e to the x will never be negative 1 because e is a positive number. Positive number to any power is a positive number. So that one doesn't give us any solutions. And we're left with just x equals natural log of 3. Let's find the inverse of a function. So to remember to find an inverse of a function, we can just switch the x's and y's and solve for y. So if I write this as y equals negative 3 to the x plus 2 plus 4, if I switch the x's and y's, I get x equals negative 3 to the y plus 2 plus 4. And then I need to solve for y. So to solve for y, I first need to subtract 4, get that exponential part by itself. So I have x minus 4 equals negative 3 to the y plus 2. Then I'll multiply everything by negative 1, and I get 4 minus x equals 3 to the y plus 2. Now I'm going to change this to logarithmic form. I need that y out of the exponent, so if I change it to logarithmic form, then I'll get that y out of the exponent. So if I do that, I have log base 3 of 4 minus x equals y plus 2. Now I can subtract 2 from both sides, and I get log base 3 of 4 minus x minus 2 equals y. And this is the inverse of f of x. Notice the graphs of both of them. This is negative 3 to the x plus 2 plus 4, and this is the log base 3 of 4 minus x minus 2. They are symmetric about that line, y equals x.